Hey everyone, and welcome back to the channel. Today, we're diving into one of nature's most intricate and often overlooked masterpieces, shells. You see them on beaches, in aquariums, or even in museums. But have you ever stopped to wonder how these incredible structures are actually made? It's a story of tiny architects, complex chemistry, and ingenious design that's truly met. When we talk about shells, we're mostly talking about mollusks. That's a huge group of animals, including snails, clams, oysters, and even octopuses and squids. Although not all mollusks have external shells, the shell isn't just a pretty outer layer. It's a living animal's home, its fortress, its protection against predators, and sometimes even a tool for movement or camouflage. So let's peel back the layers and uncover the secrets of shell formation. At the heart of shell creation is a specialized organ called the mantle. Think of the mantle as the mollusk's personal construction crew, a soft layer of tissue that completely encloses the internal organs. This amazing mantle secretes all the materials needed to build and repair the shell. It's like having your own 3D printer constantly working to maintain your home. The primary building material for most shells is calcium carbonate, the same stuff that makes up chalk, limestone, and even pearls. But it's not just any calcium carbonate. It comes in specific crystalline forms, mainly calcite and aragonite. The mollusk extracts calcium ions and carbonate ions from the surrounding water or from its diet. These ions are then transported to the edge of the mantle. Here's where it gets really clever. The mantle doesn't just spew out calcium carbonate randomly. It secretes a complex organic matrix, primarily made of proteins and polysaccharides. This matrix acts like a scaffolding, a template that guides the crystallization of the calcium carbonate. Imagine trying to build a brick wall without mortar. It just wouldn't hold together. This organic framework ensures the shell has its specific shape, strength, and even its beautiful patterns. The shell grows from the edge of the mantle, gradually expanding as the mollusk grows. It's an incremental process. New layers are added continually, meaning the oldest parts of the shell are at the apex or hinge, while the newest growth is at the outer edge. This continuous addition is why you can often see growth lines on shells. Like rings on a tree trunk, each line marking a period of growth. Some species even lay down daily or seasonal growth rings, telling a story of their life. The strength of a shell isn't just about the calcium carbonate, it's about how these materials are organized. Shells often have multiple layers, each with a slightly different composition or crystal orientation. For example, some shells have an outer prismatic layer, a middle nacreous layer that's the iridescent mother of pearl you often see, and an inner chalky layer. This layered structure makes them incredibly tough and resistant to cracking, much like advanced composite materials engineered by humans. It's an evolutionary marvel. What about those stunning colors and intricate patterns? These are also primarily controlled by the mantle. Pigments are incorporated into the organic matrix during secretion, creating stripes, spots, and swirls. The patterns can even change based on the mollusk's diet, environment, or even its mood. Some mollusks can even change their shell pattern to blend in with their surroundings, a form of camouflage. It's truly astonishing when you consider that these tiny, soft-bodied creatures can construct such robust, complex, and aesthetically pleasing structures, all without a blueprint or external tools. They are constantly repairing, reinforcing, and expanding their homes. A testament to the power of natural selection and biological engineering. From the humble snail to the giant clam, every shell tells a unique story of survival and natural beauty. So next time you pick up a shell on the beach, take a moment to appreciate the incredible journey it took to form. It's not just a pretty object, it's a testament to nature's tiny architects and their mastery of chemistry and design. If you found this deep dive into shell formation as fascinating as I did, hit that like button, share this video with your curious friends, and don't forget to subscribe for more amazing insights into the natural world. Thanks for watching, and I'll see you in the next one.